In lesson D, we are going to talk about radical expressions and specifically taking different roots of radicals. Now, first off, to evaluate the nth root of a radical, you're going to go to desmos.com, then click on functions, which is here, then click on miscellaneous, and under miscellaneous, you're going to click on the nth root. So this will help us evaluate different roots of radicals. Let's start with the definition. If you have the bth root of x to the a, this is called radical form. We can convert it into exponential form where the x is going to remain the base and a over b, this is going to be in exponential notation because now we have an exponent instead of a radical. So notice that the root becomes a denominator and the exponent becomes a numerator of the exponential notation. So if our radical form is a fourth root of 9 cubed, then 4 is the root, that'll become the denominator, and 3 is the exponent, that'll become the numerator. So I would write that as my base 9 raised to the power of 3/4. Now we're going to evaluate this using a calculator, which we'll do at the end. We have 5 to the 2/3. Now remember, the denominator is the root, so we're going to have the cube root of 5, and then the numerator becomes the exponent, so this will become the cube root of 5 squared. Okay, then you have negative cube root of 27, so the negative sign doesn't change. If there's no exponent, there's like an invisible 1 here, so we're going to have negative 27 to the 1/3 power. Okay, and then finally we have negative 9 to the 5/2, so the denominator is always going to be the root, and so you have negative. When you have a second root, you don't write that because square root is assumed to be a second root. So we have negative square root of 9 to the 5th power, and the numerator becomes the exponent. Notice the negative stays outside the radical and not inside. Now we can evaluate all these using a calculator. So you can use the radical form to evaluate or the exponential form. The exponential form is easier, but I'll show you both ways. So first, let's go to desmos.com and go to the graphing calculator. So I'm going to do the first one both in exponential and radical form. So if I were to do exponential form, I would say 9 and then go to the keyboard and click on a to the b, which is the exponent, and then write 3/4. Okay, that's one way of doing it. Now, if you want to do this using the radical form, you would go to functions, then you would go to, well, they actually changed it. Instead of miscellaneous, they just have these, but you have to scroll down and go to the nth root, which is all the way at the bottom under number theory. And again, this might change, you just have to find it. So you're going to put the fourth root, the denominator is going to be the root, and then you have 9 cubed. So again, we get the exact same answer, okay, which is 5.196, and if I round that, it'll be 2. So I'm going to write that as 5.1962. Now the next one is 5 to the 2/3. So for the rest of them, I'm not going to do them both ways. I'm just going to use the exponential notation. So I have 5 raised to the power of 2/3. This will give me 2.9240. Then I have negative 27 to the 1/3. So, and anytime there's a negative, make sure you put it outside the radical if you use radical form. But I'm going to use exponential form. So I have negative 27 raised to the 1/3 power, and this will give me negative 3. The reason it's this time an integer is because the cube root of negative 27 just means which number multiplied by itself 3 times is 27, and that's negative 3, because negative 3 times negative 3 times negative 3 is equal to negative 27. And then lastly, we have a negative, and then the square root of 9 to the 5th, or negative 9 to the 5/2 power. I'm going to once again use exponential form because it's easier. So I have negative 9 raised to the power of 5/2, and this will give me negative 243. Okay, next we're going to find the domain and range of radical functions. So the domain is going to be all the values of x for which the graph exists, and the range is all the values of y for which the graph exists. So we're going to complete the table below using Desmos.com. Okay, so we're going to graph each function. Let's start with the first one, which is g of x equals to radical x minus 3. So I'm going to clear all this. And in Desmos, I'm going to have g of x equals to, now for the radical, you can either go to the radical symbol or you can press SQRT and you have x minus 3. So here's what the graph tells us. Now for the domain, we're going to look at all the values of x, so going horizontally for which the graph exists. The first value of x for which the graph exists is x equal to 3. And then to the right, like 4, 5, 6, the graph exists everywhere. So we're going to have x equals 3 as our starting value of x. Okay, and then it goes towards infinity. So our domain is going to be bracket 3 comma infinity. Now we use a bracket anytime there's a closed circle or the number is included. And since 3 is included in our domain is going to be 3 comma infinity. Now there's another way to get the domain. So for all square root functions, let's say we have square root of a, you can't, if you take the square root of like negative 25, you'll have an error. We can't take square roots of negative numbers. We can only take square roots of numbers that are 0 and greater. Like we can take square root of 0, square root of 1, square root of 2, etc., etc. So whatever that expression is, it has to be greater than or equal to 0. So if we take x minus 3 and set it greater than or equal to 0 and solve for x by adding 3 to both sides, I'm going to get x is greater than or equal to 3. And that's what the graph told us as well, that for the values of x that are greater than or equal to 3, the graph exists. Okay, now the horizontal intercept is where the graph is going to hit the x-axis. So if I look at my graph, my horizontal intercept is going to be the 0.30 because that's where the graph hits the x-axis. So I have my horizontal intercept as 30. My vertical intercept is a point where the graph hits the y-axis. And again, if we go back to our graph, the graph never, this is the y-axis here. This vertical axis is the y-axis. The graph never hits it, so there is no y-axis. There is no vertical intercept. Okay, now let's look at the second one. We have s of t equals to radical 6 minus 8t. Now Desmos is kind of interesting because it doesn't accept any variables besides x. So even though it says s of t, I'm going to use, I'm going to clear this, and I'm going to say s of x equals to the square root of 6 minus 8x. And again, please use x. Do not use t because it won't give you the right answer. So we can see here that this time we have the highest value of x is 0.75. Now notice that this is the highest value of x. And from here, the function goes to the left or towards negative infinity. And when we write this in interval notation, you always write the smaller value first and then the higher value. So because the graph goes towards negative infinity and negative infinity is smaller than any other number, because negative infinity is a concept that numbers get smaller and smaller, that's going to come first, and the highest value is going to be 0.75. So our domain is going to be negative infinity, comma 0.75. Now notice that negative infinity and infinity are in parentheses because these are not numbers, they're concepts that numbers get infinitely bigger, infinitely small. Like we can never reach infinity. We can never reach negative infinity. So they're going to be in parentheses, whereas the values are going to be in brackets because those are actually included in our domain. You can also do this using the inequality. So remember that whatever is inside the radical, the 6 minus 8t, always has to be greater than or equal to 0. So to solve this, first we're going to subtract 6 from both sides. And if we do that, we are going to get negative 8t is less than or equal to negative 6. Now we're going to divide by negative 8. Anytime you divide by a negative, okay, anytime you divide by a negative, the inequality is going to flip. So instead of, I'm sorry, this was a greater than. So initially it was a greater than or equal to, but because I divided by negative, the inequality is going to flip. It's going to go from a greater than to a less than. So I'll write this on the side. I'm going to get t is less than or equal to, it's going to flip because we divided by negative, 6/8. And if you convert that to a fraction, we get 0.75. So you want all the numbers that are less than or equal to 0.75, which means you're going to start at negative infinity and end at 0.75. Okay, last one. Oh, and the horizontal intercept and vertical intercept, we can get those from the graph. So the horizontal intercept is this one, 0.75 comma 0, and the vertical intercept is this one, 0 comma 2.449. Okay, now same thing for the last one. We have radical 12 plus 2x. So I'm going to have 12 plus 2x. So we can see that my x values start at -6 and they go towards positive infinity. My horizontal intercept is -6, 0, and my vertical intercept is 0, 3.464. Okay, so my x values, they start off at -6 and they go towards infinity. My horizontal intercept is -6 comma 0, and my vertical intercept was 0 comma, what was it again? It was 3.464. Okay, so it says use your graphing calculator to complete the table. So for these, all you're going to be doing is you're going to be completing a table of values. So for example, the first one, it says g of x equals to radical x minus 3. So I'm going to go back to Desmos, and in my first line, I'm going to put g of x equals to radical x minus 3. And then we're asked to find g of 2, g of 3, g of 6. So I'm just going to put g of 2, and then g of 3, and g of 6. And we have our values here. Notice that g of 2 is undefined because remember the domain is 3 or greater. The x values start at 3. So at 2, the function is not defined. And then you would do the exact same thing for the other two. You would plug in the function, and you would plug in these values. Okay, lastly, for each of the functions below, determine the domain, the horizontal intercept, and the vertical intercept. So same thing as we did before, but now we're going to have to use a fifth root. So remember, in Desmos, we can use a fifth root. So for that, you would go to your functions, and in this case, they changed it up, so you're going to go to the nth root, and you're going to go to the fifth root, and your function is going to be 4x minus 24. Now here, if you zoom out, the graph goes infinitely in both directions. So because the graph goes infinitely in both directions, our domain is going to be negative infinity comma infinity. Okay, the horizontal intercept is where the graph hits the x-axis. So that'll be this here, 6, 0, and the vertical intercept is where the graph hits the y-axis, which is 0, comma, negative 1.888. All right, let's do one more. We have the fourth root of 3x plus 15. So I'm going to go to Desmos. Well, here I'm just going to use this fourth root of 3x plus 15. Notice for any even roots, we do have a domain restriction. So in this case, our graph starts at -5 and it goes towards infinity. So our domain is going to be -5, comma, infinity. So for all the even roots, we have a domain restriction. For the odd roots, we don't. It'll always be negative infinity, comma, infinity for the odd roots. Then we have our horizontal and vertical intercepts. So our horizontal intercept is -5, 0, and our vertical intercept is 0, comma, 1.968. And those will be your horizontal and vertical intercepts. If you have any questions on this, feel free to email me and I'm always happy to help out.